On this video guys, we are going to learn how to calculate for the density of ideal gases. And the gases that we will be considering here are gaseous mixtures. So, it is composed of more than one components, no? So, meron tayong mixture of gases. Paano natin kukunin yung density niya? Let us begin with the ideal gas equation, which is PV is equal to nRT. But we know that the molecular weight of the compound is equal to the weight of the compound divided by the number of moles of the compound. So therefore, makukuha natin yung ating number of moles of the compound, which is equal to the weight of the compound divided by its molecular weight. So if you're going to substitute yan dito sa ating ideal gas equation, we will have PV is equal to, substitute natin yung N, which is weight over the molecular weight times RT. And of course, dito sa ating lecture ngayon, ang gusto nating makuha is yung density, which is density is equal to weight over volume, okay, ng ating compound. So we have here the weight and we have the volume. So we can isolate this, no? So we have pressure times the molecular weight, okay, over RT is equal to the weight of the compound divided by the volume, which is density, right? So therefore, for ideal gases, the density of the gas is equal to the pressure, the molecular weight of the gas divided by RT. Okay? So ito yung ating formula for getting the density of our ideal gas. Okay? But in this equation, we are just considering one component lang, no? Isang gas lang ang ating pinag-uusapan. Now, if we are going to solve for gaseous mixtures, we have to consider yung molecular weight ng lahat ng ating component na gas sa ating mixture. And to do that, we have to get the average molecular weight. So the density of the gas, okay, we're talking about gaseous mixture here, no? So let me revise that para mas malinaw. The density of the gaseous mixture is equal to the pressure times the average molecular weight over RT. Okay? So, ito yung magiging formula natin to get the density of the gaseous mixture. Now, the question is, how are we going to get itong average molecular weight? So, the average molecular weight is equal to the summation of the molecular weight of our components, okay, sa mga gases na nasa ating mixture, multiplied to its mole fraction. Okay? Our X here is the mole fraction of the gas. So, for example, meron tayong dalawang gas sa ating mixture. In order to get that, okay, let's say we have here an example. Pag meron tayong dalawang gas, in order to get the average molecular weight, we have to get the molecular weight of the first gas multiplied to its mole fraction plus the molecular weight of the second gas multiplied to its mole fraction. Okay? So, ganyan natin makukuha yung average molecular weight. And then, kapag nakuha na natin yung average molecular weight niya, we can then substitute that here in order to get the density of our gaseous mixture. Okay, so para mas maintindihan natin, katulad ng mga ginagawa natin sa previous videos, let us solve a problem. So we have 56 grams of N2, okay, nitrogen, 44 grams of CO2, carbon dioxide, and 16 grams of oxygen, and they are placed in a container. The total pressure is 2 atmosphere. So we have to determine first the percent weight analysis of the gaseous mixture, the mole fraction of each component, the percent volume analysis of the gaseous mixture, the partial pressure of each component, the average molecular weight of the gaseous mixture, and finally, the density of the gaseous mixture. So lahat yan, sasagutan natin, ano? So, let us have our solution dito sa ibaba. So, first, unahin nating sagutan yung pinahanap sa atin sa A, which is the percent weight analysis, no? So, percent weight analysis of the gaseous mixture. So, paano natin gagawin yan? Given naman lahat ng weight ng ating components, no? So, we just need to get the total weight. Okay, so the total weight will be equal to the weight of each component, which is for nitrogen, 56 grams. For carbon dioxide, 44 grams. And for oxygen, 16 grams. So, therefore, our total weight is equal to, let us add all of that. We have 56 plus 44 plus 16, which is equal to 116 grams, no? So, we have 116 grams. So, kailangan natin makuha yung percent weight analysis. So, first, let us get the percent weight of our nitrogen. Okay, so how many grams of nitrogen we have? 56 grams divided by the total weight, which is 116 grams times 100. Okay, so our percent weight for N2 is 56 divided by 116 times 100. We have 48.26%. Okay, next we need to get the percent weight of carbon dioxide. So, ang weight ng ating carbon dioxide is 44 grams. So, we have 44 grams divided by 116 grams times 100. We have calculator natin. 44 divided by 116 times 100. So, we have 37.93%. And then, finally, yung percent weight ng ating oxygen. So, ilan yung weight ng ating oxygen? 16 grams divided by the total weight times 100. So, we have 16 divided by 116 times 100. We have 13.79 grams. 13.79%. So, this is our percent weight analysis ng ating gaseous mixture. So, ngayon naman, sagutan natin yung B, which is asking us to get the mole fraction of each component. So, we need to get the mole fraction of each component. So, unahin natin yung nitrogen. So, ano yung weight ng ating nitrogen? Our nitrogen is 56 grams. Weight ng N2 is 56 grams. Now, what is the molecular weight of N2? So, nitrogen has a molecular weight of 14 grams per mole. So, dahil meron tayong N2 here, dalawang nitrogen, so we will have here 14 times 2, which is 28 grams per mole. So, kunin natin yung number of moles ng ating N2. So, we have 56 grams of N2 times 28 grams of N2 per 1 mole of N2. Okay? So, our grams of N2 will be cancelled out. Therefore, ang magiging sagot natin dito is yung number of moles ng N2, di ba? So, let us calculate for that. 56 divided by 28. So, we have 2. Okay? So, therefore, we have here 2 moles of N2. Okay? And to be specific, we have here gram mole of N2, di ba? So, let us correct that. So, we have 2 gram mole of N2. Okay, so ngayon naman, kunin natin yung number of moles ng ating CO2. So, I will not write it anymore, no? Kasi naipakita ko na siya dito sa nitrogen. So, sulat na lang natin ano yung weight ng ating CO2, 44 grams. So, we have 44 grams of CO2 times, okay, so anong molecular weight ng CO2? Oxygen is 16 times 2 will be 32 plus 12. It will give us 44 grams of CO2 per 1 gram mole of CO2. Okay? So, as you can see, our 44 grams of CO2 will be cancelled out. So, ang magiging sagot lang natin dito is 1 gram mole of CO2. Then, finally, kunin natin yung number of moles ng ating oxygen. So, ano yung weight ng ating oxygen? We have 16 grams of oxygen. Okay, so, let's have 16 here. So, 16 grams of O2. So, ano yung molecular weight ng O2? Oxygen is 16, but we have 2 atoms of oxygen. So, we have 32 grams of O2 per 1 gram mole of O2. Okay? So, our gram mole of O2 will be cancelled out. So, solve natin yung ating gram moles. So, we have 16 divided by 32. So, we have 0.5. Okay? So, we have 0.5 gram mole of O2. Okay, so meron na tayong value ng lahat ng ating component in gram mole. So, ilan yung total gram mole sa ating mixture, no? So, we have 2 plus 1 plus 0.5. So, we have 3.5. So, our N total is equal to 3.5 gram mole. Okay? So, kunin natin yung mole fraction ng bawat component natin. So, unahin natin yung mole fraction ng N2. So, yung mole fraction is the number of moles ng ating component divided by the total number of moles. So, para sa ating N2, we have 2 gram mole of N2 divided by 3.5 gram mole, okay, in total. So, therefore, our XN2, okay, so let me write it here. XN2 is equal to 2 divided by 3.5, which is equal to 0.57. Okay, so yan yung ating mole fraction ng N2. Now, the mole fraction of CO2 is equal to, yung CO2 natin is 1 gram mole. So, we have 1 over 3.5, which is equal to, ulit, 1 divided by 3.5 is 0.286. Okay, 0.286. And then, yung mole fraction ng ating O2 is equal to 0.5 divided by 3.5. So, our mole fraction of O2 is equal to 0.5 divided by 3.5, which is equal to 0.143. Okay, so, nasagutan na natin yung B. Meron na tayong mole fraction ng lahat ng ating component. So, now, let us answer C. C is the percent volume analysis of the gaseous mixture. So, C is, let's see, C. Okay, so for C, we need to get percent volume analysis. Okay, so ang given lang natin is itong weight and mole fraction. Ano? Yan lang naman na meron tayong data. Now, how do we get the percent volume for ideal gases? We need to take note yung natutunan natin sa Amagat's law o partial volume. Okay, so ano ba yung sinasabi dito sa Amagat's law o partial volume? So, natutunan natin that in our ideal gases, the volume fraction is equal to the mole fraction. So, kung na-miss ninyo yan, I suggest you watch again our previous video about Amagat's law o partial volume. How do we get that? So, sabi natin, di ba, based from the ideal gas equation, PV is equal to nRT. So, let's say meron tayong dalawang gas, which is gas A and gas B na nagmix. So, if you're going to get the volume of our gas A, we have VA is equal to the number of moles of A RT over pressure. No, we are in ideal gas, and we are referring to constant temperature and pressure here. So, kapag meron naman tayong component B, so we have the volume of gas B is equal to the number of moles of B RT over P, diba? But what is the total volume? The total volume is equal to the volume of A plus the volume of B. Now, let us get the volume fraction, which is VA over VT for our component A. No? So, VA is equal to NART over P divided by the total volume natin, which is the number of moles total, RT over P. So, what will happen? Dahil constant pressure and temperature tayo, so our RT and P will be cancelled out. Okay, so therefore, ano yung naiwan? We have VA over VT is equal to NA over NT. So, ano ba tong NA over NT natin? Diba? NA over NT is our mole fraction, diba? So, therefore, yung volume fraction natin is equal sa ating mole fraction. So, meron na tayong mole fraction, no? Ang mole fraction natin is ito. Now, how are we going to get the percent volume? We just need to multiply this to 100. Okay, for example, the percent volume for N2, okay, let's write here volume. Percent volume for N2 is equal to our mole fraction, which is 0.57 times 100. This is equal to 57%. So, what is our percent volume for CO2? Our mole fraction for CO2 is 0.286 times 100. So, this is equal to 28.6%. And our percent volume for O2 is equal to, okay, our mole fraction is 0.143. Multiply that to 100. So, we have 14.3%. So, nakuha na natin yung volume analysis, no? Yung percent volume analysis ng ating gaseous mixture. Now, let us solve D. Ano sabi sa D? Partial pressure of each component. Okay. So, D is asking us to calculate the partial pressure of each component. Okay, so this time, we are going to refer yung natutunan natin sa Dalton's law of partial pressure. Ano naman yung sinasabi natin dito sa Dalton's law of partial pressure? Dito, natutunan naman natin that mole fraction is equal to the pressure fraction. Ano ibig sabihin yan? If we have, again, component A and component B sa ating gas, so we have gas A, we have gas B mixed, no? And considering we have an ideal gas here, so meron tayong partial pressure ng A and partial pressure ng B. And the total pressure is equal to the sum of our partial pressure, which is PA plus PB. Okay? So yan ang ating pressure total. So again, magbabase tayo sa ating ideal gas equation, which is PB is equal to nRT. So if we are now referring again to our component A, okay, our gas A, okay, ang partial pressure ng ating gas A at constant volume is equal to the number of moles of our gas A times RT at constant temperature, no? Ganun din sa ating component B. It will be the number of moles of B times RT. Now, if we want to get the pressure fraction, we will have pressure of A over pressure of, okay, total pressure. Now, if you're going to solve for partial pressure of A here, we have NA RT over V. And for our total pressure, we have NT RT over V. Now, we are in constant temperature and volume, no? So, this will be cancelled out. So, therefore, nakikita natin dito, our partial, or our pressure fraction, which is PA over PT, is equal to our mole fraction, which is NA over NP. So, katulad lang yan ang ginawa natin kanina, no? We have here our mole fraction. So, kung gusto natin makuha yung partial pressure ng ating N2, for example, we will have partial pressure ng ating N2 divided by the total pressure is equal to the mole fraction of N2. Okay, so given sa atin yung total pressure, di ba? Sa ating given. Total pressure is 2 atmosphere. So, therefore, pwede nating makalculate yung ating partial pressure. So, our partial pressure of N2 is equal to the mole fraction of our N2. Ano yung mole fraction ng N2 natin? 0.57. So, 0.57 times our total pressure, which is 2 atmosphere. Okay, so therefore, our partial pressure of N2 is equal to 0.57 times 2. So therefore, it is 1.14 atmosphere. Now, the partial pressure of CO2 is equal to its mole fraction, which is 0.286. 0.286 times 2 atmosphere. This is equal to 0.286 times 2 atmosphere is equal to 0.572 atmosphere. And for the partial pressure of O2, 0.143. Tama ba? Lang natandaan ko eh. 0.143. Okay, tama. Times 2 atmosphere. So, this is equal to 0.143 times 2 atmosphere. 0.286 atmosphere. Okay, so nakuha na natin yung partial pressure ng bawat isang gas natin dito sa ating mixture. Okay, so nasagutan na natin yung D. Now, let's go to E. Now, E, we need to get the average molecular weight of the gaseous mixture. Okay, yan na yung topic natin. Okay, so we need to get the average molecular weight, okay, ng ating mixture. So, sinabi na natin yung formula kanina, no? The average molecular weight is equal to the summation of the molecular weight of our components times its mole fraction. Okay, Okay, so gawin natin yan. So, the average molecular weight is equal to, meron tayong tatlong gas dito, no? So, unahin natin yung molecular weight ng ating nitrogen. So, sabi natin N2 is 28, di ba? So, we have 28 grams per gram mole multiplied to the mole fraction of N2. So, mole fraction ng N2 natin is 0.57 plus the molecular weight of CO2. So, ang molecular weight ng CO2 kanina nakuha na natin, which is 44 grams per gram mole times the mole fraction of CO2. So, ano yung mole fraction ng CO2 natin? Ito, kanina kinuha na natin, 0.286. And finally, molecular weight ng ating O2, which is dalawang atom ng oxygen. So, 16 times 2, we have 32 grams per gram mole times its mole fraction, which is 0.143. Okay, so, makukuha na natin ngayon yung average molecular weight. Okay, so, solve natin siya, no? We have first 28 times 0.57 plus we have 44 times 0.286 plus 32 times 0.143. So we have 33.12 grams per gram mole. Okay, so ito yung average molecular weight ng ating gaseous mixture. Okay, so ganyan ang pagkuha ng average molecular weight, guys. So finally, sa ating F, we need to get the density of our gaseous mixture. Okay, so sabi natin kanina, no, yung ating formula in getting the density of the gaseous mixture is equal to the total pressure times the average molecular weight divided by RT. Okay, so it seems may kulang sa ating given. Dapat given yung ating temperature here. So, dahil hindi siya given, so dapat nandyan yun. So, let's say our gases are mixed in ambient temperature, no, which is 25 degrees Celsius. Okay? So, to get the density of the gas, we need to multiply itong ating total pressure, which is 2 atmosphere, times the average molecular weight, which is 33.12 grams per gram mole, divided by our R. So, ano yung R natin? Our R is 0.08205. Okay, liter atmosphere per mole Kelvin. Then our temperature is 25 plus 273 Kelvin. Okay, so check natin yung ating mga units. Atmosphere will be cancelled out, mole will be cancelled out, temperature will be cancelled out. So, maiwan sa atin is grams per liter, no? So, let us try to solve that now in order to get the density of the gaseous mixture. So, the density of the gaseous mixture is equal to 2 times 33.12. Divide natin sa ating R, 0.08205. Then, divide natin sa ating temperature, which is 25 plus 273. So, therefore, ang density ng ating gas is 2.71 grams per liter. Okay, so ito na yung answer natin. This is the density of our gaseous mixture. Okay, so meron lang kulang sa ating given. It should have temperature. Kaya we just assumed now that it was mixed in the ambient temperature. Well, that's all for now, guys. Thank you very much and have a nice day.